What's up, civil engineers? This side Sandeep Singh, professional estimation engineer and corporate trainer. I welcome you in our official YouTube channel, Reinforced Quantity Surveying and Training Private Limited. It's a venture company of Reinforced Construction and Project Private Limited. Today, I am here for the discussion of isolated footing from live project drawings. In this session, I will explain you how to study and analysis the structural drawings of isolated footing and how to take up the quantity from the drawings and how to calculate the quantity of concrete work and shuttering area in a Excel sheet in very detail. Okay, so you can see here this is the structural drawings of isolated footing. In this drawing, footing scheduling is given here. You can see we have three footings: F1 footing, F2 footing, and F3 footings. Okay, that length and width is given here. This is the column scheduling. We have a three columns: C1 column, C2 column, and C3 columns. Okay, F1 footing have a C1 column, F2 footing have a C2 column, and F3 footing have a C3 column. This is the length and width of column is given here. This is the top view, or we can say plan of isolated footing, or this is the cross section of this isolated footing. Okay. This is the column center line plan of isolated footing. With the help of this plan, we do the marking of position of footings and columns on the construction side. You can see here we have a number of footings here in this plan. Firstly, you can see this is the F1 footing. F1 footing have a 10 numbers, F2 footing have a 6 numbers, and F3 footing have a 4 numbers. Okay, length and width is given here. F1 footing 1.4 meter by 1.4 meter. Okay, and capital D is given here 230 mm, or capital small d is given here 230 mm, and capital D is given here 450 mm. Okay, you can see here this one. This is the cross section of isolated footing. This is the PCC, plain cement concrete. That ratio is given here 1:5:10. The thickness of PCC is 100 mm, and the projection of this PCC from the face of footing is 75 mm. Okay, capital D is given here, that is 450 mm for F1 footing, or small d is given here. Okay, that is 230 mm for the F1 footing. Okay. This is the 75 mm projection from the face of column. With the help of this 75 mm, we find out the top length and top breadth of isolated footing. Okay, you can see here this is the bottom length of isolated footing from here to here, or this is the bottom breadth of isolated footing from here to here, or this is the top length, small l, or this is the top breadth, small b. Okay, or this is your column. Okay, column is given here 450 by 230. Okay, bottom length and bottom breadth of isolated footing is given here 1.4 meter and 1.4 meter, but top length and top breadth is not given here, that is L and B. So how to calculate the top length and top breadth? For the calculation of top length, we have a column length is given here 450 mm. So we add projection 75 mm this one side, or 75 mm so this one side. Okay. The same for the breadth. Breadth is given here 230 for the column. We add this 75 or this 75. Okay. So this is the structural drawings of the isolated footing. जो इस तरह से दिखाई देता है drawings में. यदि आप actually construction side में देखेंगे तो कुछ footing आपको इस तरह से दिखाई देता है. Actually construction side में isolated footing आपको इस तरह से दिखाई देगा. इस तरह से देख सकते हैं आप. तो ये आपका आइसोलेटेड फुटिंग, इसको हम लोग ट्रेपोजोइडल फुटिंग भी बोलते हैं. इस फुटिंग में क्या है कि आइसोलेटेड फुटिंग है, इसमें जो हम लोग शटरिंग अप्लाई करते हैं केवल बॉटम पार्ट में शटरिंग अप्लाई करते हैं. जो टेपर्ड सेक्शन है इसमें शटरिंग अप्लाई नहीं करते हैं. इफ वी अप्लाइंग द शटरिंग इन अ टेपर्ड सेक्शन, तो हाउ टू पोर द कंक्रीट, so that is the main issue. Okay, so we applying the shuttering only in a bottom part, but that the tapered section that is be cast manually. Okay, this is the Excel sheet for the estimation of isolated footing. In this Excel sheet we calculate the quantity of concrete, the quantity of shuttering area, and we also calculate the quantity of cement, sand, एंड एग्रीगेट। किसी भी फुटिंग को कास्ट करने में कितना कंक्रीट लगेगा ये डिपेंड करता है कि इस फुटिंग का वॉल्यूम कितना है। ओके, सेम किसी भी फुटिंग को कास्ट करने में उसमें कितना शटरिंग लगेगा ये डिपेंड करता है कि उसका सरफेस एरिया कितना है। तो आप देख सकते हैं इस पिक्चर में, ये आइसोलेटेड फुटिंग है, इसको हम 2 पार्ट में डिवाइड कर सकते हैं। ठीक है, अब इस फुटिंग को कास्ट करने में कितना कंक्रीट आएगा ये डिपेंड करता है कि इसका वॉल्यूम कितना है। और इसका वॉल्यूम फाइंड आउट करने के लिए हम इसको 2 पार्ट में डिवाइड कर सकते हैं। पहला, फर्स्ट पार्ट, that have a bottom part, this is the rectangular section, and second have a tapered section. Okay, so we calculate the volume of bottom section and tapered section, then we add both, we get the total volume of this isolated footing. Okay, so let's see how to calculate the quantity in an Excel sheet. This is F1 footing that is given in a 10 numbers. Okay, column description C1, column length is 450 mm, that is given in a drawing, you can see here. This is the column length for the C1 column, 450 by 230 mm, 450 mm length, 230 mm breadth. Okay, this is the F1 footing, that length is 1.4 meter, breadth is also 1.4 meter, that we are using 10 number. Okay, so this is the column length 0.45 meter, column breadth 0.23 meter. So this is the column projection from the face of column 75 mm. You can see here, this is the column projection 75 mm. Okay, both sides 75 mm. And this is the footing bottom length that is given in a drawing 1.4 meter, footing bottom breadth that is also given in a drawing 1.4 meter. This is the footing top length. Okay, that is 0.6 meter, that is not given in a drawing, we calculate. See here how to calculate this footing top length. Okay, column length 0.45 meter, that is given here, then we add projection 75 mm 0.075, then we again add 75 mm 0.075, so that's our 0.6 meter. Okay, so this is the footing top length 0.6 meter. Same our top breadth, we add column breadth and projection 75 mm and 75 mm, so we get footing top breadth, that is the capital D, that is given in a drawing. This is the small d, that is given in a drawing. Okay, this is capital D 450 mm, or this is the small d, that is given in a drawing. Okay, after this we find out the edge. Okay, this is the edge from here to top portion, so we minus capital D to small d, so we get the edge. Okay, so this is the edge, we minus capital D to small d, so we get the edge. After this we find out the bottom area. Okay, bottom area, this is the formula for the bottom area, bottom length into bottom breadth. This is the footing bottom length, this is the bottom footing bottom breadth, we multiply, so we get the bottom area. Next have a top area. To find out the top area, we have a top length into top breadth. Okay, so top length is given here, that we already calculated, top breadth is given here, we multiply, so we get the top area. After this we calculate the bottom volume. To calculate the bottom volume, we have a formula, bottom area into depth. Okay, so we already calculated bottom area and multiply by the small d, so we get the bottom volume. After this we calculate the top volume. Okay, for the calculation of top volume, that is the tapered section. Okay, so this is the formula for tapered section, h by 3 bottom area, top area, square root of bottom area into top area. That all the things we already calculated here. This is the bottom area, top area. Okay, this is the h, so we directly put in a formula. Okay, h by 3, so this is your h, then we multiply by the bottom area, then we multiply by the top area, plus square root of bottom area into top area, so we get the top volume, that is tapered section. Okay, after this we add the top volume and bottom volume to get the volume of one isolated footing. So this is the volume of one isolated footing, we add the top volume and bottom volume. This is the total volume. We multiply by the number of footings, that is 10 into volume, so we get the total volume. Okay, after this we calculate the shuttering area. We already discussed we applying the shuttering in isolated footing in a only rectangular portion. For the calculation of shuttering area of rectangular portion, we have a formula: 2 times of bottom length plus bottom breadth into small d. Okay, that have a formula: parameter into depth. Okay, so we using this formula: 2 times bottom length, this is bottom length, and bottom breadth, we multiply by the depth, so we get the shuttering area. This is the shuttering area of one footing. Okay, after this we multiplying by the number of 10, so that is the total shuttering area of F1 footing. Okay, next, this is the total volume of concrete, 6.6 meter cube. How to calculate the quantity of cement, sand, aggregate from the this volume that we discuss. Okay. In this drawing, the quantity in this drawing the grade of concrete is given here, M25 for the footing. You can see here. So we calculate the quantity of cement, sand, and aggregate from the this volume. Okay. For the M25 grade of concrete, we have a ratio 1:1:2. One is the one for the cement and one for the sand and two for the aggregate. Okay, this is the standard formula for the calculation of cement volume into 1.54 into cement ratio into 29 divided by cement ratio plus sand ratio plus aggregate ratio. Same formula for the sand volume into 1.54 into sand ratio into 35.31 divided by cement ratio plus sand ratio plus aggregate ratio. Same formula for the aggregate. Okay, we put here total volume. Okay, and we put here cement ratio, that is 1, that we multiply by the 29. Why we multiply by the 29? Okay, if we multiply by the 29, we get the cement directly in a bag. Okay, if you don't multiply by the 29, we get the cement in a meter cube. Okay, when we go for the market for the purchasing of cement, that comes in a bag. So that's why we multiply by the 29. Okay, same here. What is 1.54? Okay, 1.54 is the dry volume factor. 1.54 is the dry volume factor. Okay, when we pour the concrete in a beams, in a columns, in a footings, that is in a bed form. Okay, but we calculate the quantity of cement in a dry form. Okay, so to compensate the volume, we multiply by the 1.54. Okay, when we mix the cement, sand, and aggregate, after this we mix the water, so the volume is shrink. To compensate this volume, we increase the volume of concrete 54% extra. So that's why we multiplying by the 1.54. Okay, so we applying this formula here for the calculation of cement quantity. Okay, this is the total volume, then we multiplying by the cement ratio, then we multiplying by the dry volume factor. After this we multiplying by the 29 and divided by the ratio of cement ratio plus sand ratio plus aggregate ratio, that is 1 plus 1 plus 2, total 4. Okay, so we get the 73 bags of cement for the casting of total F1 footings in a drawings. So this is the formula for the sand. Okay, volume into 1.54 into sand ratio into 35.31. Why we are using 35.31? If we don't multiply by the 35.31, we get the sand in a meter cube. Okay, but we purchase the sand in a cubic feet, so we directly multiply here cubic feet. Okay, 1 meter cube have a 35.31 cubic feet, so we get the sand in a cubic feet. Okay, we applying the formula, so we get the sand. Okay, next have aggregate. For the aggregate, we have a same formula: volume into 1.54 into aggregate ratio into 35.31 divided by the cement ratio plus sand ratio plus aggregate ratio. So we get the total quantity of aggregate, that is 179 cubic feet for the casting of total F1 footing. Okay, so once we prepare this type of standard sheet by applying all these standard formulas, okay, after this all the things are very simple. Okay, then we go for the second F2 footing, that have a 6 number. This column have a C2. That column length have a same 0.45. Column breadth have a same 0.23. This is the column projection, same 0.075. And footing length, we can see footing length from the drawings. Okay, for the F2 footing, that is given 1.6 meter by 1.6 meter. 1.6 meter by 1.6 meter. For the calculation of top length and of this footing, we go for the drag, this one. This is the capital D that we can see from the drawing. For the F2 footing, that is given 500 mm, or small d is same for all, that is 500 mm, 0.5 meter, that is same 0.23. Then we drag this one, so we get the capital H. We are already applying the formula here. Okay, so this is the bottom area. This is bottom volume. We are already applying the standard formula. We go for only drag, so we get the quantity. This is bottom volume. This is total volume. This is shuttering area. Dry volume factor is same for all. Okay, we are already applying the standard formula for the cement calculation. So we just go for the drag. Okay. Then we have a same F3 footing. That have 4 number, C3 column. Column length have a same 0.45. Column breadth have a same 0.3, and projection have also same 0.075. And for the footing bottom length and for the bottom breadth, you can see from the drawing that have 1.9 meter by 1.9 meter. That's have a capital D, 600 mm. Or 1.9 meter by 1.9 meter. Capital D is given here 0.6 meter. That is same 0.23. Okay, that we go for the drag 0.37. Okay, so you can see here we calculate the this one. After this we go for the total volume. So 17.71 meter cube concrete are required for the casting of all the isolated footings. And 28.70 meter square shuttering area required for the casting, and that have a cement bag. 197.79 cement bags are required for the casting of all the footings. And 240 CFT sand are required for the casting of footing. And 481 CFT aggregate are required for the casting of footing. So you can see here, this is the complete estimation of isolated footings. Okay. In a first line, we are using the standard formulas for the calculation of bottom area, top area, bottom volume, top volume, and shuttering area. Then for the calculation of cement, sand, and aggregate. After this, we input only specification data, footing length, breadth, and depth. We go for the direct, then we calculate the all the quantities. Okay, so this is the complete estimation of the isolated footing. I hope you are getting it. Okay. Due to COVID-19, we all of are at home. Stay happy and stay safe and healthy. If you have any doubts regarding this session, so you can ask me in a comment section. Okay. Thank you so much for the supporting and encouraging our RQST team. Don't waste time in a COVID-19 period and try to learn more things that help you in a future to grow very fast in the construction industries. Okay. If you want more content like this, please like, share, and subscribe our YouTube channel, and always keep learning.